Hello everyone! Welcome to our physics class. I am your science teacher, Mark Anthony Atienza. Today, let's discuss about accuracy, precision, and the different errors of measurement. Our objective for today is to be able to differentiate accuracy from precision and be able to differentiate random errors from systematic errors. So now, let's try to gain a basic understanding of the concept of accuracy. By definition, class, accuracy refers to the degree to which a measured value agrees with the correct value for that measurement. That means when you are able to obtain a measure close to the true value or exactly the same with the true value, you are accurate. On the other hand, precision refers to the degree to which repeated measurements agree with each other. This means that when you are able to reproduce the same results every time you conduct a measurement, that means you are precise. Remember, class, that accuracy is equivalent to the words closeness and exactness. On the other hand, precision refers to the reproducibility and repeatability of your measurements. Let's try to deepen our understanding by joining a darts tournament. Who among you class knows how to play darts? Okay, we have many students who knows how to play darts. Now, let's try to have our first round in the darts tournament. Any volunteer? Okay, Cassie, I'll be giving you 5 pins and I want you to aim right in the bull's eye. Ready? First pin, Cassie. Second pin, Cassie. Third. Fourth. And the last one? Oh, sorry, Cassie, you didn't even hit the bull's eye. Now, class, I want you to comment on Cassie's accuracy and precision. Anybody? Yes, John. That is correct. You are right that Cassie had poor accuracy and poor precision. Why? Because the darts are far from the bullseye and the darts are likewise far from each other. And therefore, we can conclude that Cassie had poor accuracy and poor precision. Let's have round 2. Yes, Carlos. Again, the same mechanics. I want you to hit the bull's eye. Ready? First pin, Carlos. Second pin. Third. Fourth. And the last? Okay, class, I want you to comment on Carlos' accuracy and precision. Anybody? Yes, Cassandra. That is correct. Carlos had high accuracy because he almost hits the bullseye. However, he has poor precision because the darts are far from each other. Let's have the third round. Yes, Jessica. Jessica, please hit the bullseye in 3, 2, 1, go. 1, 2, 3, 4, 5. Oh, you're out of pins. Now, class, how could we comment on Jessica's game? Okay, that is correct. She has poor accuracy but high precision. Why? He has poor accuracy because the darts are far from the bullseye. However, he has high precision because the darts are close to one another. Okay, let's have next round. Maybe it would be good if I'll try to test my skills because it has been ages before when I had my last game in a darts tournament. Okay, my first spin class, please watch. Okay? 1, 2, 3, 4. Oh! There! Still hit the bullseye. And my last spin would be like this. Go. Oh, there! I consecutively hit the bullseye right off the mark. How can we comment on my accuracy and precision? That is correct. I had high accuracy because all the darts hit the bullseye, and I have high precision because all of my darts are close to one another. And therefore, we can all agree that I am the winner in this darts tournament. Thank you very much. Let's further deepen our understanding of accuracy and precision using real-life examples. Let's say that you were given a paper which measures 13 inches. And out of curiosity, you tried to measure the length of this paper. You obtained the following measurements: 13.1 inches, 13.2 inches, and 12.9 inches. My question is it accurate? That is correct. It is accurate because your measurements is very close to the true value. On the other hand, are you precise? Excellent, because your measurements are close to one another. Let's try a different example. Your mom has asked you to buy 10 kilograms of rice. Out of curiosity, you tried to measure the weight of the rice. You obtained the following measurements: 3.2 kilograms, 3.2 kilograms, and 3.2 kilograms. My question is it accurate? That is correct. You are not accurate, your measurements are not accurate because you are far from the true value. However, are you precise? Good job. It is precise because you obtained the same results all over again. Another example. You are in a laboratory and you were given an unknown substance which has a true value of 3 grams. You measured that substance and you obtained the following measurements: 2 grams, 4 grams, 3 grams. My question is it precise? That is correct. You are not precise because your measurements are far from one another. But are you accurate? Good analysis. You're accurate because when you take the average mass of that substance, you will obtain 3 grams. Let's see. 2 plus 4 plus 3, that makes 9. Divided by 3, that gives you 3 grams. And therefore, you are accurate but not precise. Let's raise the difficulty by 1 by trying to read graphs and tables. Let's have the first example. 2 students performed 4 trials to measure the mass of 5 milliliters of water. The true value for the mass of water is 5 grams. Let's see their graphs. Here is student A, here is student B. Class, what can we comment on the accuracy and precision of both students? Excellent. Student A is accurate and precise. Why? Because his measurements are close with one another and his measurements is likewise close to the true value, which is 5 grams. On the other hand, how about student B? Nice analysis. Student B is inaccurate because his measurements are far from the true value, which is 5. However, he is precise because his measurements are close to one another, which is 7 grams. Let's have a different example. Students measure the temperature outside on a nice sunny summer day. The actual temperature was recorded to be 30.5 degrees Celsius. Here are the results. My first question, class, is which result is the most precise? Good. It is student number 1. How about which result is the most accurate? That is correct. It's student number 2. It seems that you had gained a deep understanding of accuracy and precision. Let's check your understanding using this very tricky question. Is precision dependent on accuracy? Who says yes? Who says no? The correct answer is it's a no. Why? Because there are times that you can be accurate but not precise, and there are times that you are not accurate but you are precise. So we can conclude that precision is independent of accuracy. It seems that we already had a deep understanding of accuracy and precision. Let's learn about the different errors of measurement, starting with random errors. What are random errors? Random errors exhibit a chance difference between the observed and true values of something. What we should remember here is the phrase chance difference. What does this mean? This means that your measurements are sometimes too high or too low. Remember, random errors, sometimes too high or sometimes too low. On the other hand, systematic errors exhibit a consistent or proportional difference between the observed and true values of something. What you should remember here is the phrase consistent or proportional difference. This means that your measurements are always too high or always too low. To gain a better understanding of random and systematic errors, let's check this diagram. Take a look and analyze. Let's assume that this is the true point or the true value. We can say that the measurements or your values are found in either of the two directions. It's sometimes too near and sometimes too far. So that means this exhibits a random error. On the other hand, when you exhibit a systematic error, your measurements are only found in a single direction. It may be too near or too far from the assumed true point. Let's establish deep understanding of random and systematic error using some problems. Problem number 1. You forgot to reset your weighing scale to 0.000. So your measurements are all wrong. My question is, what kind of error had you committed? That is correct. It is a systematic error. Why? Because your measurements will always be too heavy because there is a problem in your equipment. Let's have a different example. The tape measure that you use to measure the length of an object had been stretched out. As a result, all your measurements were wrong. My question is, what kind of error had you committed? Excellent analysis. It is systematic error because all of your measurements will be too small because there is a flaw in your equipment. Next problem. You measure the mass of 17.43 gram ring 3 times using the same balance and get slightly different values. You obtain 17.46 grams, 17.42 grams, and 17.44 grams. What kind of error had you committed? Good job. It is a random error. Why? Because you may have noticed that your measurements are sometimes too high from the true value or sometimes too low from the true value. Let's try to analyze this problem. Everyone's watch shows a different time. Everybody can relate from this, right? My question is, what kind of error are we committing? That is correct. It is a random error because we tell time that is sometimes too early or late. Are there any questions? Good job. Let's check your understanding using another tricky question. Here is the question. What is mainly affected by random errors? That is correct. It is the precision of your measurement. Why? Because if we are to look at this diagram, we can say that the precision of the measurement is affected since the measurements are far from each other. Another tricky question. What is mainly affected by systematic errors? That is correct. Obviously, it is the accuracy of the measurement. Why? Because if we are to check this diagram, we can say that all of your measurements are far from the true value, and therefore your accuracy is heavily affected by your systematic error. Are there any more questions? Good. For your homework, I want you to study this problem. 4 groups of Earth science students use their Global Positioning System or GPS to do some geocaching. The diagrams here show the students' results relative to where the actual caches were located. What I want you to do is to comment on the accuracy, precision, and the error committed by each group of students. Are there any questions? None? Okay, if that's the case, let's see each other tomorrow. Goodbye, class.